So it's actually not the right thing to say, because it's the other way around. Dear students, today's topic is charging and discharging of a capacitor. Often we call this circuit as an RC circuit. So today we will be talking about this circuit and the charging characteristics of this circuit. So before getting into this problem, before talking about this problem, let me give you some brief idea about an RC circuit. So what is an RC circuit? RC circuit is something like this. It consists of a voltage source, or you can say it's a battery. It should be connected to a capacitor, right? So if we have a voltage source or a battery of 20 volts, and if this thing is connected to a capacitor, let's say the value of the capacitor is 500 microfarad. So if I simply ask you, so what will happen in this case? Previously we talked about loops, we talked about branches as well. So if I tell you that it's a closed loop, right? So what will happen in this closed loop? Will the current be, the current is going to start flowing through this circuit? Should it happen? Should I say that the current will start flowing through this circuit? The answer to this question is no. So it will not exactly, the current will not start flowing through this one, because it's a capacitor, it's not a resistor. So capacitor has a characteristic of charging and discharging. You need to remember this one. It has characteristics of charging and discharging. What does that mean? That actually means that when this capacitor is connected to a voltage source, when it is connected to a voltage source, it actually either charges, not either charges. If it is connected to a voltage source, it gets charged up. When it is not connected to a voltage source, rather it's connected to, let's say, a resistor or something else, so that gets discharged. So we will talk about this later on, but for the time being, just remember that for the current to flow through this circuit, we need another resistor, right? So when we connect this resistor in series with this capacitor, the current starts flowing through this closed circuit, right? And what will happen? The battery will eventually, this battery has a voltage of 20 volts, right? But after some times, all of these voltages will be accumulated by this capacitor, and it will be gradually drained. This voltage will be drained gradually. So let's say the resistor value of this one is R is equal to 1K, right? So this is what happens in the charging phase. So this is what happens in the charging phase. So few minutes before I said that the capacitor has a characteristics of discharging as well. So let's say if we have a circuit like this, a capacitor C is connected to a resistor, what will happen in this case? What will happen in this case? The capacitor, we are assuming that this capacitor is initially charged. Let's say this capacitor holds an initial value of 20 volts. So when the current starts flowing through this closed path, the capacitor will gradually, the potential will be gradually decreased. Potential or voltage, whatever you call it. So it will be gradually decreased, and the energy will be dissipated through this circuit. So we will talk about this later on. So let's now move into this charging phase. Let's talk about this circuit. So here, as you can see, this 20-volt battery is connected to a resistor and then it is connected to a capacitor. We have a switch over here. So when the switch is connected to this point, right, when the switch is pressed, we have a switch over here. So when this switch is pressed, so the circuit gets completed, right, and current will start flowing through in this direction, isn't it? The current will start flowing like this, and once the current starts flowing through this circuit, charge will be accumulating in this capacitor. In other words, we can say the capacitor will start getting charged. It will be charged up, and after some instant, this the voltage of this battery will be drained, and this total voltage will appear across this capacitor, right? So it has some characteristics actually, right? So in other words, we can also say when the switch is turned on, what will happen at that case? Just the moment the switch is turned on, the current starts flowing. Let me write this down. When switch is turned on, at that moment the voltage across the capacitor should still be 0. You need to remember this one, right? And what will be the voltage across this resistor? Can you say? The voltage across this resistor is denoted with VR, and it should be 12 volts. Okay, you need to remember this one. Why I am telling, that's the when switch is closed, current starts flowing. At that very moment, voltage across this capacitor is 0, and all of the voltages is dropped across the resistor at that point. Because we need to remember one thing, the voltage across the capacitor does not change instantaneously. It takes some time to accumulate that energy, or you can say to drop that voltage. And after some time, so what will happen after some time? When the capacitor is fully charged, after some time, let me write this down. The capacitor will be fully charged. At that moment, our VC will be 12 volts, and VR, voltage drop across the resistor, should be 0. So these are the two instances you need to remember. So you can say after some time, or finally, you can say whatever you want to call it, it's okay. So then you can say no current passes through the capacitor at that moment, right? When all the voltage is accumulated across the capacitor, all the voltage drop is occurring across the capacitor, no current passes through the capacitor. The current passes through the circuit is used for charging the capacitor. You need to remember that one. And there is another thing you need to remember, that is the equation. What equation? Equation that explains the charging of the capacitor. Equation that explains the charging of the capacitor is denoted like this. V is equal to, let me write this like this way, V is equal to E multiplied with 1 minus e to the power minus t over tau, t over RC. Okay, so what is this one? What about this V is actually the voltage across the capacitor. This V is the voltage of the battery or the cell, this one, this 20 volts. And then we have this 1 minus e to the power minus t over RC. This RC is actually nothing but tau. This is also called time constant. Instead of writing minus t over tau, you can write 1 minus e to the power t by RC. That's also fine. So another thing you need to remember, that when the charging is being done, the capacitor will charge progressively and the graph will look like this. The charging behavior looks like this. At this horizontal axis we have time, here we have the voltage of the capacitor, and as I have told you here, time constant is tau. This is called time constant, and this is denoted with tau, and the equation for this tau is equal to RC. So this thing can easily be calculated using the R and C's that are given in the question paper. These are very easy things. And before solving this simple circuit, we need to know some parameters, and it will be helpful for us in solving the rest of the problems. So one thing is, so as we already talked about, is the time constant. Time constant is denoted with tau. Tau is equal to RC. One thing you need to remember is tau, this time constant tau, and t, small t, are not the same thing, right? Tau and t are not the same thing. This is time constant, this is t. Okay, and as I have told you before, that when this capacitor is connected to a voltage source, the voltage source will be drained eventually, right? The current will start flowing and the capacitor will be charged, and after some time all of this voltage will appear across this capacitor, right? And at that moment current will stop flowing. So you might be asking yourself how much time it will take for the capacitor to charge. So this thing you need to remember, usually the capacitor gets fully charged after 5 time constant. So this is a thumb rule, you need to remember this one. Capacitor usually gets charged after 5 time constant. So in this case we have 5 time constant, 5 tau, right? Or you can say 5 into tau is nothing but RC. So R is also given, C is also given. Putting these values of R and C, we can easily calculate the 5 time constant, and from this one we can know that this much amount of time it will take for the capacitor to fully charged. And another thing you need to remember is percentage of charge. So sometimes you might be asked to find out that after one time constant, how much the capacitor is charged by how much percentage. You might be asked like this, or maybe the question may be after 2 time constant, how much percentage the capacitor is charged. The question might be like this. So let me write this down here, over here. So I have made a table over here. So as you can see over here, we have tau 1 time constant, 1 tau, 2 tau, 3 tau, 4 tau, and so on, right? So let's say what happens after one time constant. this capacitor gets charged by how much percentage, or what is the voltage that appears across the capacitor. If we want to find out after one time constant what is the voltage across the capacitor, how we can solve that one? As I have told you before, that the charging characteristics of a capacitor is denoted by this equation: V is equal to E into 1 minus e to the power minus t over RC, right? So if we just simplify this one a little bit, what we will get here, the value of E is 20, then we have 1 minus E over T by RC, right? So in this case we can easily replace T with, the time is one time constant, right? Instead of writing T, we can replace it with one time constant, or tau, right? Tau is nothing but RC. I have already told that one, tau is nothing but RC. They both are the same thing. So instead of writing minus 1 tau, we can easily write minus 1 RC over RC, right? This RC and RC gets cancelled out. We are left out with 20 into 1 minus E over e to the power minus 1. So that actually gives us a value of what? Can you tell? So what should be the value of this one? So it actually gives us a value of 12.64. So after one time constant, the voltage that appears across the capacitor is 12.64. So if I ask you what is the value across the capacitor after 2 time constant or 2 tau, so what will you do? You use the same equation over here, right? And instead of this T, you need to write down minus 2 RC. Why? Because time here is, because in this case time is nothing but 2 tau, right? In the question itself I told you what happens after 2 time constant, what is the value across the capacitor. So instead of T, you replace this one with 2 tau, and tau is nothing but RC, so 2 RC, right? So RC gets cancelled out, we will be left out with e to the power minus 2, right? And finally the equation will be, the equation should look like this: 20, 1 minus e to the power minus 2. So if we calculate this one, we will get a value of 17.29. So same goes for the other time constants as well. If we try to calculate this one, we will see that after 3 time constant, voltage that appears across the capacitor is 19. After 4 time constant, if we use the same equation, if we calculate, we will see that the voltage that appears across the capacitor, it's 19.63. What about this one? Voltage that appears across the capacitor should be 19.86. So this is how it goes, right? So can we assume something from this one? Is there anything that we can conclude? So the thumbs rule that I told you here is actually applicable, right? I told you that capacitor usually gets fully charged after 5 time constant. So we are seeing the same thing over here as well. After 5 time constant, voltage across the capacitor is almost equal to the battery, that is 20 volts. It's not exactly the same, but it's almost the same, right? So this is what we need to remember: capacitor gets fully charged after 5 time constant. Okay, So what about this one? How much percentage the battery is charged? Not the battery, sorry. How much after one time constant, how much percentage the capacitor is being charged? So how can we do that? It can easily be done using this formula, right? So if we just tweak this one, this original formula a little bit, from this we can easily write this, right? V over E is equal to 1 minus e power t over RC. If we just simply multiply this one with 100, we'll be getting how much amount or percentage of charging, right? Percentage is done in this manner. We all know that, right? Percentage is done by the input parameter divided by the output parameter. Is it okay? Is it the right thing to say? So it's actually not the right thing to say, because it's the other way around. It's the opposite way around. Output over input. And if we do it like this, we'll be getting the percentage, right? Let's not get into that details. For the time being, you can calculate the percentage charge by using V over E is equal to this one. This is nothing but the extension of this formula. We have written down this over here, this thing, multiply with 100, we'll be getting the percentage of charged. So if I ask you how much amount is charged after one time constant, what should you write? After one time constant. So instead of writing t, after one time constant means 1 tau, right? The time is after 1 tau. T is equal to 1 tau. So instead of t, you replace this one with 1 tau, right? And this tau is nothing but RC, right? So 1 RC. So replace this t with 1 RC. RC and RC gets cancelled out. E to the power minus 1. So you will be left out with E minus 1 multiplied with 100. And if you calculate, you will be getting how much? 63.21. So if I ask you how much amount is being charged after 2 time constant, after 3 time constant, after 4 time constant, and after 5 time constant, you need to use the same procedure over and over again. The same procedure has to be used over here. So for 2 time constant, you need to replace this t with 2 tau. Tau is nothing but RC. So RC and RC gets cancelled out. So e to the power minus 2. So in that case, the equation will be E1 minus e to the power minus 2 multiplied with 100, right? So let's not get into that one. I think and I hope you will be able to find it out. So I'm just writing down the answers over here. So after one time constant, 63.21% of the capacitor is being charged, and after 2 time constant, 86.5% being charged, and after 3 time constant, 95% charged, after 4 time constant, 98.2% charged, and after 5 time constant, it's almost 99.3% charged, right? So this is how it goes. You need to remember this one. So this is actually the charging characteristics of a capacitor. Ready to let go. You decide if you ever